Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional video to show students how to use the Excel template that I created for doing hypothesis testing with the mean. So if you open up Moodle, you can see that the Excel template is located under Chapter 8, Hypothesis Testing with Mean, Chapter 8, Section 4, using Excel. So open that up. And notice that you have these cells highlighted. This is the cells that you should be plugging in information from the problem. All the other cells have formulas, so you don't want to mess with those because that'll affect the template. I'm going to use a homework problem from Chapter 8, Section 4 as kind of an example to use the template with. So here's the problem. Assuming simple random sample has been selected from normally distributed population. Test the given claim, identify a null alternative hypothesis, test statistic p-value, and then state a conclusion. So a simple random sample of 25 filtered 100 millimeter cigarettes is obtained and the tar content of each cigarette is measured. The sample has a mean of 19 milligrams and standard deviation of 3.53 milligrams. Use 0.05 significance level to test the claim that the mean tar content of filtered 100 millimeter cigarettes is less than 21.1 milligrams, which is the mean for unfiltered king size cigarettes. Do the results suggest, if anything, about the effectiveness of the filters? So the first thing is to identify the null, which is H sub 0, hypothesis, and the alternative hypothesis, H sub 1. So in this case, we are assuming that the null hypothesis is 21.1. So in other words, we're assuming that the amount of tar that you would get from a filtered and unfiltered cigarette would be equivalent. And so that would be either A or B. Notice that the null hypothesis should always be a statement of equality. So we can automatically go ahead and eliminate C and D. And then the alternative we're saying is that the filtered cigarettes has less tar. So the alternative hypothesis is that the true mean is less than 21.1 milligrams, so then A should be the correct answer here. Alright, identify the test statistic. So this is where the template's going to come in handy. So we want to put in the sample mean, which was given to us from the problem, which was 19 milligrams. We want to put in mu, which is the population mean, which comes from the null hypothesis. We assume that to be 21.1. S is the sample standard deviation, which was 3.53 milligrams. And N is the number of objects in our sample size. So in this case, we had a sample of 25 cigarettes. Alpha is the significance level, which in this case, it says use a 0.05 significance level. So we'll keep that at 0.05. And then notice that everything else gets calculated for you. This is degrees of freedom, which is N minus 1. Here are the critical values for each type of test. So if the alternative hypothesis is greater than, that's the critical value. So that's separating the boundary from what's acceptable and what's not acceptable in regards to accepting or rejecting the null hypothesis based off a significance level. So this is the t-score that would be needed, in which we would have an area or probability of 0.05 in the right tail of a t-distribution. This is the critical value for less than, which would be the t-score, in which we would have an area to the left equal to alpha, 0.05. And then this is the critical value for not equals to. So if we split alpha into each tail, so 0.05 divided by 2, that would be the t-score, that would be the boundary, so that we would then have half of alpha in each tail. Alright, and then this is our test statistic. The test statistic comes from the formula here. This is from the notes, so it is sample mean minus our value for mu, the population mean, which comes from the null, divided by the sample standard deviation divided by root n. So that formula is already in the Excel spreadsheet here, and so all of these values that you plugged in from the problem are used to calculate that. And so this test statistic is negative 2.9745. So rounded to 3 decimal places, negative 2.975. All right, identify the p-value. Okay, so how this works is these match up in columns. So this is the p-value for a greater than test. This is the p-value for less than test. These are p-values for not equal to test. And you actually have two different p-values, one if the test statistic is positive, one if it's negative. So you got to actually look at not only alternative hypothesis, but what the test statistic is in terms of the sign. So in our particular problem, we were doing a less than test. Our alternative hypothesis was mu is less than 21.1. So I would want to look at this column here, the one in the middle, and so this is the p-value that matches with it, 0.0033. And then we use that p-value to then do a conclusion. So we compare p-value to alpha. If our p-value is less than alpha, then that's enough evidence to reject the null hypothesis. So we would want D here. We reject the null. There is sufficient evidence to support the claim that the mean tar content of filtered cigarettes is less than 21.1. And then this would give us enough information to then conclude that the filters for these cigarettes are indeed effective. That we have proven statistically through our sample that the mean tar content is less than those of unfiltered cigarettes. All right. So hopefully that gives you a little bit of introduction into how to use this template. You can certainly use this template on your homework, on your quizzes. And if you have any questions in regards to it, please let me know. All right, thanks and have a great day.